Hi friends, welcome back. Today we are going to solve LintCode problem 632 binary tree maximum node. So before we start looking details in this problem and its implementation, I just want to mention that I often create LeetCode solution videos using Java J2E technologies as well as interview helpful videos. If you are a Java developer or J2E developer, I create often videos that will be helpful for your coding interviews as well as your phone or initial screening interviews. So please check out my playlist. It has a lot of good videos in it. And also please subscribe to the channel. Your subscription will be really helpful to reach to more people like you. So let's look into this problem. So find the node with largest value in the binary tree and return it. So they have given us a binary tree here. As you can see, this is one of the binary tree they have given, and you can see like it starts with this is the root. So this is the root 1, and then it is like left child, right child, right? -5 3, and again 1 2 is left and right child of -5, right? So here you can see 1 2 and then -4 -5. So this is the binary tree that is given to us. And as you can see, if you look at these nodes, 3 is the maximum value, right? All other values are lesser than 3. So we have to return the node with the maximum value. So so this is the max node is given to us. So we will just create one tree node called as max, and we will just say null in the beginning. Tree node is the class that is for all these nodes we are using tree node class, right? And it has a value and it has a left and right subtree child, right? So what we will be doing is now we will just create one recursive function called as search max, and then it will find out the maximum node in the binary tree for us. So let us just write that function. So this is private void and then search max, and then we will just pass tree node, right? Tree node and root here. So we will pass this and we will write this recursive function. So our base condition for this recursive function, first we will write if we are finding a null node, right? If root is equal to null, then in that case we will just simply return null, right? Because there is nothing we have to do in that case. So we will just return null. Otherwise we will take a value of this tree node, right? Like for example, if we are at 1, then we will check the value, and if it is uh, we will make that as a maximum tree node, right? So in the beginning what we can do is we will just assign before we start as the maximum node here will be the root, right? We will just assign as the root will be the maximum, and then we will compare all the nodes with this in the recursive function. So what we will do here after the base condition is if root.val is greater than max.val, right? Whatever current maximum, if we are finding a better value than maximum, more value than maximum, then what we will do is we will just update our max to the node that we are looking at, right? So that's what we will do. So and after we are done, then we have to still go to the left side of the tree and right side of the tree, right? uh, so we will go both left and right side. So as you can see, root dot left we will say here, and then we will again say root dot right here, right? And this is our recursive function. This one, once this function is finished, we will get our maximum node and we will just have to return that maximum node. So let us quickly run and make sure this is working. So this is the same example that they have given us, right? Return null is Java 29, right? So Java 29. So we will just return root here, right? Return, we have to just return, right? Because our return type is void, so we don't have to return. So our solution is getting accepted, right? Here 3 and 3 we are getting correct result. Now let's just modify this tree a little bit, so we can try with different values. So let's say one here we are having one here, right? One. So one we will put two children here with more values. So for example, let's put 10 and 20 here, right? 10 and 20. So I'll show you how the tree looks like. So the tree looks like this. So one has now 10 and 20. So in this whole tree, 20 is the maximum value. So 20 it should return us. So let us run our test. Uh, Number format exception. Oh, we have to. Yeah, there is a space, right? So it does not accept space. That's why I think. Yeah, now you see you are getting like a correct value here, 20. That is what our tree's maximum value is, 20, right? So you can use this data structure viewer to see our tree. So see like you can change the values and see how the tree look like. So now 20 we are getting because 20 is the maximum value. So this is the way you can implement the binary tree maximum value. So our code got accepted with almost 93% better in the performance. So that's pretty good. So one more time, we have just created a max tree node variable outside here, and we have initialized it to root, and then we called our recursive function, and we will keep checking if we are finding any value which is more than our current max value, right? And in that case we will update it, otherwise we will go and search in the left subtree, or and we will search in the right subtree for the maximum value. So that is the way. So if our tree has order of, basically if the tree has n number of nodes, then we have to visit all the n number of nodes. So its time complexity is order of n in that case, where n is number of nodes. Um So space means we are not using any other extra space or anything. Only one variable we have used is tree node variable max, right? So it is, you can say it is order of constant. O1 is the space complexity. So as I said in the beginning, I often create LeetCode solutions in Java and J2E. So please check out my LeetCode playlist. It has over 70 videos explained with examples, as well as I have created Java J2E helpful videos for if you are preparing for Java interviews, coding interviews, or phone interviews. It explains what questions to expect and how to answer those questions. So please check it out. Also, please subscribe to the channel. Your subscription will be really valuable, so the videos can reach to more people like you, and they can also benefit from it. So please subscribe, and thanks for watching the video.